Welcome to the Industrial IoT Spotlight, your number one spot for insight from industrial IoT thought leaders who are transforming businesses today. With your host, Eric Walenza.
Welcome back to the Industrial IoT Spotlight podcast. I'm your host, Eric Walenza, CEO of IoT1, the consultancy that helps companies create value from data to accelerate growth. And our guest today is Taylor Cooper, co-founder and CEO of MistyWest. MistyWest is an engineering and design consultancy that creates technically complex, intelligent, connected devices that accelerate the world's transition to a sustainable future. In this talk, we discuss the current state of embedded computing and best practices for crossing the valley of death from concept to production for a connected device. We also explored the development path of a new system-on-module solution that MistyWest is developing for use in low-power computer vision applications. If you found these conversations valuable, please leave us a comment and a 5-star review. And if you'd like to share your company's story or recommend a speaker, you can email us at team@iot1.com. Finally, if you have an IoT research strategy or training initiative that you'd like to discuss, please email me directly at erik.walenza@iot1.com. Thank you.
Taylor, thank you so much for joining us on the podcast today.
Yeah, thank you very much for having me.
So I'm looking forward to this now even more so because you mentioned that you're a fan of the podcast, and that strokes my ego. So really, really happy to have you on. Also, I think it's a very interesting topic here, a very timely topic, because we're going to be discussing embedded computing, and because of the chip shortage, this is something that's front of mind for a lot of companies around the world right now. Right? How do we things that maybe have been hidden to senior management in some cases are now kind of front and center? How do we get product out the door when we don't have the perfect supply chain?
Yeah, absolutely. It's a conversation we get pulled into a lot these days.
Yeah, I'm sure. So let's get into that topic later. First, I'd love to just understand a bit more about yourself. It looks like you had a passion in this right out the gate. Just based on your CV, you were doing kind of a junior firmware engineer with experimental cosmology lab while you were still an undergrad. Is that right? When did you first touch the topic of embedded computing?
Yeah, I think that's a fair place to start. I used to work at the experimental cosmology lab at UBC in Vancouver, where we were building. I was writing drivers for Linux for basically a PCI card that was reading out bolometer arrays so that you could map the cosmic microwave background radiation.
And then just tracking your career here, you were team lead. I think this is probably also while you were in university for a NASA project, the Regolith Excavation Challenge. And then, if I'm correct, your first job was then as a mechanical engineer with Boreal Genomics, where it looks like you were developing kind of prototypes for, what is this, gene editing, or what were you working on here?
Yeah, so I after working on that NASA Centennial Challenge team, I landed a job at Boreal Genomics. That was a startup by the director of the engineering physics program at UBC, and it had a metagenomics application. So we were building instrumentation for basically purifying very long strands of DNA based on a kind of interesting technology called synchronous coefficient of drag alteration, but I'll spare you the details maybe. And then from that, we leveraged that same technology to do a very novel type of basically DNA enrichment, non-PCR based DNA enrichment. So there was a lot of complicated instrumentation and really embedded system design related to that, with the goal being, how do you extract fragments of carcinogenic DNA from blood so you can diagnose cancer at a much earlier stage. The technology all worked, and the company ended up getting acquired by Natera fairly recently, I think maybe 3 years ago. But there were some other competitive issues, I guess you could say. It's a long conversation, and it's not really about industrial IoT, so maybe I'll spare you the details.
Yeah. Well, that's certainly been a booming area of the market, so I can imagine that, it was a lot of complexity on the competitive side. And then back in 2014, it looks like you, together with a group of other people, set up MistyWest. And here on your CV, you were first engineering physicist, and then you've kind of now become the CEO. but you were also a founding employer. So what did that look like? Did you all know each other, or did somebody kind of set up the company and then recruit you shortly thereafter? What was the background story for the setup of MistyWest?
Yeah, I mean, I guess I live in a tight-knit community. The company was founded by two other engineering physics grads, basically from the same program. So I got introduced to them actually working at my previous job. And then myself and a couple other people, we kind of came together. I was one of the co-founding employees back in, this would be like 2014, 2013. We were around 6 people then. And we've just kind of been growing steadily from there, working on all kinds of IoT projects, mostly in the commercial industrial space.
Yeah, some really interesting projects. So we'll have to deep dive a couple of those. I want to wait a minute to get into the details of MistyWest, but I've got one question. So the name MistyWest, I'm from Portland, Oregon, actually. So I'm imagining this is kind of describing our climate, but is that right? Is this like the misty Northwest, or where's the name coming from?
Yeah, no, that's where the name comes from. There's actually a bit of a funny story there. So the company got incorporated quite a few years earlier, like I think actually in 2009, by two of the two founders, Josh Escher and Lee Christie, and they wanted to create a skimboarding company. And then they shelved that almost right away, but picked it back up again after a while, after they'd cut their teeth working in engineering for a while, and decided, hey, they were doing a bunch of consulting work on the side, and they were like, why don't we just make this a full-time thing? And they were like, well, we already have this company rolled out, so let's just go with that. There's been conversations about changing the name in the past, but it is kind of unique and generic, and sometimes that's actually great as far as Google is concerned.
Yeah, absolutely. Yeah, it's funny because, I mean, if you look at companies large and small, there's really no best practice for names, right? I mean, ours is IoT One, and you can imagine that was a fairly conscious choice to kind of tether ourselves to this topic of IoT. But then then the business expands, and you start looking at it and saying, well, maybe I should choose something a bit more generic, a little bit more amorphous. I don't know. But in the end, people have no problem. We're a consultancy, and people ask us to do all sorts of things that have no relation to IoT. So I think end of the day, people are working with the team more than they are with the name.
100%, yeah.
So before we get into what MistyWest does in particular, I'd love to discuss a bit more of the topic of embedded computing and how it's changed. And I think one good frame to kind of think of that through is this project that you were working on with NASA back in 2009. So it sounds like you were working on kind of hardware for excavation, I guess, on kind of foreign, on the moon or planets. And the topic then would be, what has changed between now and then? How would you design differently given the toolkit that you have available now versus the toolkit that you had available then? And then also, probably equally interesting, what has not changed so much? I mean, are there particular aspects either of the technology stack or the design process, et cetera, that have remained more or less static over the past decade?
Yeah, that's a great question. So obviously that was a long time ago. Some of the things that have changed a lot is, I mean, when we were working on that project, like Arduino was kind of just getting started. Like the Arduino Uno was the thing. Now we're seeing companies like Sony, for example, release their like S Presence line, and they'll talk about how they have like Arduino-like interfaces and functionality. So you have these major silicon manufacturers who are standardizing around the Arduino IDE just because so many people know about it. So like that's a big change, obviously. We also used a LiDAR for the project. So just to give a little context on the project too. So this is one of NASA's Centennial challenges. They also had a space elevator challenge, and I think they had one around like a glove solution for astronauts. So these were, I think, launched back in like 2006 or 7. When NASA announced that it wanted to return to the moon. So the Regolith excavation challenge was really about, hey, if we're gonna build a permanent moon colony, which is they're supposed to be having people landing on the moon right in like the next 2 or 3 years here. Using the dirt that's there, the regolith that's there, is really important. So this was basically a competition to find new ways of moving that dirt around. So we had to design a relatively autonomous robot. So yes, we used Arduino microcontrollers for some small pieces of it, but we also needed a way to kind of navigate with a time delay, because they were expecting having a human controller back on Earth, and there's like a 15-minute time delay, which makes it a little hard to control. We settled on a Hakoyu LiDAR solution that was basically line scanning and had something like a 15 FPS frame rate, and I think it was like $5,000 or $6,000 USD at the time. Now you can go and look at like the Velodyne Puck or some of the solutions out of Aster and get something that is like a 2D sphere with a much higher pixel density and like 10 times the refresh rate for that price point. So LiDAR's also come a long ways. In terms of what's stayed the same, I think there are some things that really haven't changed too much. The actuators, they're pretty similar. A lot of the wiring and electronics design is pretty similar. We're still writing firmware occasionally on an Arduino, depending on what it is. We use a lot of STM32s these days. I don't know. There's kind of some of those core things that haven't changed too much.
Yeah. I imagine, let's say back then, if you were to be operating on the moon and you have a 15-minute latency, you need the equipment to be relatively self-sufficient in terms of taking actions, I suppose, right? Otherwise, it's going to take you forever to do anything because you're going to be sending commands, assessing the situation. And so edge computing, what do you see as the potential for edge computing to, well, maybe how are we doing this when we're on Mars today with a rotor? I guess to some extent, that's what we're doing, right? There's no kind of real time or even, I don't know what the latency is there. It's probably hours, right? So how are we managing that today on these remote applications?
Yeah, I don't know offhand, but I think it is on the order of hours. And they do path planning. And I think the robot has some ability to basically make some decisions on its own. So like if it gets into trouble or say like torque on a certain motor exceeds a certain threshold or whatever, it will stop and allow the driver to reassess. But it's not super fast moving around, right? They're really careful with how they drive these things because they don't want them to get stuck. So yeah, in terms of like having like a fully autonomous vehicle just making decisions on its own, that's not really something that is getting done right now, I would say. Though obviously going back to the moon, that's something that's going to be of increasing interest. And the moon is a much easier place to deal with that than say Mars. Like a 15-minute delay versus a multi-hour delay is a pretty big advantage.
Yeah, exactly. And then so that's from a technical perspective. In terms of the way that you work, and maybe this is just going to reflect to an extent, you as you are today with something like 15 years of experience versus you as yourself back then. But in terms of how you manage a embedded computing project, have the best practices changed, or are we fundamentally, walking through the same steps just with a different toolbox?
Yeah, I think some of the things have gotten easier. So there's things like the Yocto project for Linux that allow you to basically use recipes to generate your own version of Linux in a relatively straightforward fashion. So there's kind of more firmware libraries. And there's also a much bigger open source hardware community now, which can be really great. It also means there's kind of more things to choose from at the module level. So you can buy like a time of flight depth sensor and things like that. There's lots of different options there if you wanted something, as opposed to having to like figure out how to make your own structured light sensor from scratch. So there's a lot of things that make some of the early product development easier. Yeah, but a lot of it has kind of stayed similar. The reality is with product development, there's always a lot of uncertainty. Honestly, some of the biggest uncertainty we deal with and we help our clients with is around actually validating their business model and market uncertainty, where, it's very easy to get people to commit on paper to, hey, we want to buy this thing at that price point. But, when you actually put the thing in front of them and it has all of its flaws and all of these issues, and there's edge cases that have been handled, sometimes those things don't really materialize. So we always argue or advise our clients to go with, a minimally viable approach and try to iterate, what is the minimum thing that you could sell that solves the problem, the core problem of related to your company's mission, and how do we get there as quick as possible and try to get out into the market and validate that, and then iterate from there, make improvements and all of that stuff. So that piece has really kind of stayed the same, though I think if you go back 15 years, waterfall was a lot more common. The methodologies were less agile. So there's practices from software that have been kind of slowly percolating into hardware more and more, which is a good thing.
Yeah, I was discussing over a coffee this morning with a company that is an advisor of a company that's building a kind of a mechanical solution for energy storage. and he was, they're trying to fundraise now, right?
Mm.
And so in order to fundraise, and they need to prove, that there's customers that have some kind of significant interest in the solution, when the solution is really 5 years away from generating any revenue, right? And kind of how do you do that, right? And this is a bit of an extreme case, right, where they have a long path to revenue, but I think it's not that extreme. I think with a lot of hardware, there's some kind of multi-year path, and lining that up in advance. So maybe this is a good jump off for what you guys do at MistyWest. So this actually surprised me a little bit that you're so involved there, because your website is very much around the technical capability. So obviously you have a very deeply technical team for developing solutions. Can you give us the kind of the high level value proposition, and then we can look a little bit step by step on where you work with companies along the path?
Yeah, absolutely. And as you're mentioning that example, in a bit here, I'll mention a company that kind of has that same challenge, in that there's a very long horizon with this deep tech to getting it, to a place where you can actually make revenue. So how do you bridge that is a real challenge. In terms of what we do at MistyWest, we're an engineering consultancy who offer product development services. So we try to pride ourselves in offering full stack services. We have a couple of industrial designers, some mechanical engineers, electrical, firmware, software. Basically, we want to be a place where you come and you might have something you want to measure, some kind of, maybe you need a camera sensor or some kind of novel sensor. You want to measure that and get that data into the cloud so you can do something with it, make some inferences, and we'll help build that IoT solution out. Basically, as a full stack team, we primarily work in the commercial and industrial space. So if it's a consumer good, if you want to make a smart dog collar or something like that, we'll probably refer you to someone else who has a bit more experience at the true high volumes. And then if it's something that is a bit more on the deep tech side, we're a company founded by engineering physicists. We have an engineering physics PhD on staff who used to lead the Queen's University Engineering Physics Department. We have kind of a very deep understanding of first principles understanding of some of the underlying problems for these harder technology ideas.
Mm. And so if I'm looking at your website and some of your examples here, I mean, you have a kind of a really broad range, which I think really, reflects the long tail of solutions in the industrial IoT space, right? That we're really looking at a lot of niches that can be extremely meaningful, but it's very different from consumer, and that everybody has, all consumers have kind of a similar set of challenges. Whereas when you're looking at, the industrial space, you just have these tens of thousands of niches. But I mean, you have everything here from polar bear trackers for the World Wildlife Foundation to outdoor signage solutions for Amazon. Who would you typically be working with? Is it, it looks like it's a mix here of almost nonprofits, some startups, and then some very large corporates. How do you balance this quite diverse portfolio?
Yeah, it's definitely a mix. So we've worked with in the past with Amazon, Google, Microsoft, Facebook. So all of the large FANGs companies. Typically, we work with their research groups. We also work with some mid-sized companies and some startups. We try to keep a healthy blend. To be honest, we don't want to have one monolithic customer. Consultancies like ours that tend to do that can have a bad experience when that company decides to move on. And then, who do we work with at those companies? So for the FANGs companies, it'll be someone in their research group often. So like Microsoft Research or, Google X. They might have some ideas they want to quickly try and find answers to and vet out. And you sometimes will have, relevant expertise for those questions and allow them to just move really quickly and get some answers. And then for, your mid-sized companies, we can talk to, say, a product manager potentially, or a head of R&D, or somebody really in even VPs or C-suite who have an initiative of mind. They have a problem and they need someone who can execute on an IoT solution, building a custom hardware and basically integrating on the software backend side. And then with startups, I'll often find myself playing a bit of an advisory role, helping them understand how do you go from where you are now to seed funding to your Series A, and what does a product development roadmap look like that is actually feasible, and when should you hire staff versus when should you look at hiring a consultancy. So one of the roles I hold right now is an investigator at CDL Vancouver, so the Creative Destruction Lab. It was spun out of University of Toronto Business School. I'm forgetting the name offhand, but I think they have like 20 chapters worldwide or something like that now, and that's kind of the role I'll play there. So we'll advise them at first, and when it makes sense, if they really understand what their problem is, and it becomes an execution problem, it's like, okay, let's go fast. That's where we'll step in and help. But really, we're just trying to have an impact. As a company, we have kind of aligned ourselves to the UN Sustainable Development Goals. So we're looking for projects that help advance those. So things like related to clean tech, clean energy, those kinds of things, inclusive technology. We don't want technology that, really only benefits some narrow niche of society. So we look for projects like that. The WWF project is an example where, it's not the most lucrative thing, but global warming is a real concern, and polar bears are at extreme risk. And, for that project, what they had was a collar dating back to the 1970s using a satellite network. There are a bunch of problems with that. Not only is it a risk for the bears, but they fall off all the time. The cost of putting a collar on the bear is something like $50,000 because you need a helicopter and a tranquilizer gun to even go put it on. And you can only put it on the female bears because the male bears, their necks are so wide. They're wider than their skull. So we help basically take that technology, into the 21st century. So we did a bunch of RF design to get the antenna miniaturized, and then used more modern batteries, more modern electronics, optimized everything for low power and, low temperature, really, because this thing needs to survive for around a year on a polar bear's ear. So that was one of the projects that I think is maybe a bit more impactful and definitely more interesting.
Yeah, interesting. I guess if you're doing something for Google, their help, you basically you're trying to help them validate some probably technical concept. If it's for World Wildlife Foundation, I suppose they already understand the end solution and they're looking for a technical solution that kind of meets specs, but they already know the application has value and what that is. If you are working with a startup, then there's this kind of fuzzy area where they have a concept. They have maybe some loose validation, having conversations that point them towards a direction. But until you get kind of product in somebody's hand, it's really hard to understand what interest in that solution is going to be. How do you, as somebody that's kind of helping to bridge, and that's the valley of death, right? Where a lot of startups kind of fail to make it through. How do you manage that tension between kind of the need to get as robust and credible customer feedback as possible, which would push you towards kind of investing heavily in a more comprehensive solution, versus the need to manage risk and go quick, which would push you towards having a very lean solution that's just kind of a bare bones prototype. And I guess you're kind of iterating back and forth. But what would be the journey? So let's say somebody comes to you with a strong concept and wants help kind of getting this to a stage where they can go to manufacturing. How would you break that down in terms of development feedback loops?
Yeah, so in the case of a startup, I can actually pull an example for this. So one company we're working with, Ideon AI, they're a spin out from Triumph, a local particle accelerator, and they're doing muon tomography. And they first started talking to us maybe 4 or 5 years ago. Muon tomography is basically, if you think of like X-rays, muons are like X-rays, but much higher energy, so they can go through, up to 1 kilometer of rock. And muon tomography, usually where it happens these days is in like the Large Hadron Collider. So if they want to understand particle physics, they're looking at muons. But there's actually muons showering down on the Earth kind of every moment from high energy particles hitting our atmosphere. So if you can figure out how to measure those underground, you can basically infer the density of the rock that muon traveled through, which allows you to make line of sight or direct line measurements of significant amounts of rock. So a good way of understanding the technology would be using an analogy. So if you think of what MRI scans have done to enable minimally invasive heart surgery like stents, a technology like this could have a similar impact on mining, which is a really relevant thing nowadays, given the need to transition to clean energy. So there's expected to be something like a $12 trillion shortfall in terms of cobalt, lithium, nickel, and copper in the next, I think, 30 years or something like that between now and 2050. So it's a huge, huge problem. And mining companies don't really have a great answer to exploration right now. Like, it's very hit or miss. A lot of the obvious surface minerals aren't easy to. They're not like if there's an ore vein on the ground, like by now it's been mined out for the most part. So they need to start looking at subsurface solutions. So this startup came to us 4 years ago. That's the background on the application, just so people understand. Came to us 4 years ago, and they built basically a box, a 1 by 1 by 1 meter box, using basically the exact technology out of the particle accelerator. So they just took some dev kits, slapped it together, and threw that in a mine somewhere. And that's really a great way to go about it if you can. Is just do something minimally viable. Try to do it with sweat equity. Try to call up whoever you can. Maybe you have a friend at BHP or whatever, and get them to let you stick your detector in their mine for a little bit to collect some data. And then, use that and the size of the problem you're solving to generate some interest. Raise that Series A, look for some raise seed funding and look for some non-dilutive funding. Like a lot of these startups we work with, especially in the deep tech space, it's very important for them to find non-dilutive funding at the start. There's a lot of government-based funding, like in the US, you can find funding through DARPA and through there's a bunch of other. I think there's an energy group as well, like DARPA. I can't remember the name of it offhand. And then in Canada, there's a whole bunch of other bodies like NSERC and entities like that. So finding that non-dilutive funding, and then when you get to a place where you've got that initial data, you've got some people who are excited about it. That's when they came and talked to us. And we basically advised them. They were looking at miniaturizing. They wanted to get this 1 by 1 by 1 meter box into a 10 centimeter circle so that they could put it in a borehole. So that now you don't need to have a mine existing for you to use this technology. You can just drill a hole and throw it in the ground. That's a pretty big challenge. It's a big engineering lift. And, they had a good understanding of what the opportunity was there. So that's a place where it made sense to engage someone like us. And we basically advised them. We said, hey, don't look at that microsemi polar fire FPGA, because even though it has good specs, it has very poor documentation, and you're going to have a hell of a time finding a developer later on to support that, because it's a very niche product. So we instead pushed them towards like a Xilinx Sync or something where it's an FPGA that it has very good adoption generally in the community, and it has things like a dedicated Linux SoC sitting right next to it, which can handle all of like Ethernet communication, things like that. So, that kind of high level advice. And we basically took them from that 1 by 1 by 1 meter box and got them down into that 10 centimeter circle. And now they're deploying, I think they've deployed something like 50 detectors in the wild, and they're looking to deploy 500 in the next year. And we're basically helping them scale up all of their manufacturing and things like that. And, we're slowly basically working ourselves out of a job there as they scale. And I mean, there's pieces where it really makes sense for us to hold on to things, but there's also places where, we'll help them to hire quality engineers and set up their own manufacturing and things like that.
Yeah, great. No, that's a perfect example. I mean, it's such a niche case. At least there, very clearly who your customer is, right? So there's no uncertainty about the question and the customer, but proving out the technology, I'm sure is a kind of a costly effort. In this case, just to understand the solution, so you drill a borehole. Is it you're drilling kind of horizontally on a slope, and then you're going from the ground, and then you have the receiver above ground, and you're looking through, or can you drill vertical and then kind of have a diagonal? Just to understand how that would work in practice. I'm just curious about this case.
Yeah, you can drill vertical or at a diagonal, and then the way the technology works is there's basically these scintillator fibers that are interlaced in a special way inside the detector, and when the muon passes through the detector, you can tell by which scintillators it hits and when. So there's a very precise timing problem. You need to have like hundreds of picosecond accuracy on timing for when photons arrive at the detectors at either end of this. It's basically a 3-meter tube with a 10 centimeter diameter in a 10 centimeter diameter circle. You can use that to know what direction the muon came from. And the muons are coming in at all different angles. They just kind of come in randomly. They're not going to come from the other side of the Earth, obviously, because they're not going to pass through the underside of the Earth. But if one came through, kind of where it came from. And from that, you can also measure how much energy it has. And from that, you can get an idea for how dense was that rock it came through. Now, the one challenge here is that, there's not a ton of muons that are coming through all of the time. It's not like you just take a picture with sunlight. You have to leave those detectors in the ground for a little while to get enough muons to go through them. But the alternative really to get a picture like that is, drill 300 boreholes instead of 6. So it's a pretty compelling value proposition when, it costs you upwards. It can easily cost you $50,000 per borehole or something like that. And then when it comes time to do extraction, right, like you have a much better picture of what it is you're looking at potentially. It doesn't work for everything because not everything has a density contrast, but it's very interesting when it does work.
Okay. No, that's great. I mean, so that's kind of precision mining. I mean, aside from saving money for the mining company, this saves a lot of, every time you drill a borehole, you're probably clearing forest and so forth, right? To get in there. And so there's a certain kind of, there's an environmental element here as well. There was another case that you mentioned, maybe a bit of a different perspective here, but this is a smart city application where you're building your own IP. So this was a question I had. I mean, obviously you're in the situation where you have a lot of technical competence and you're constantly being confronted with interesting challenges. So I've got to imagine you're sitting over lunch every day and somebody says, "Hey, why don't we do this?" And it's always a temptation for an entrepreneur to stay focused. But what are you doing in terms of exploring areas where you can build your own IP today?
Yeah. So I mean, the chip shortage really led us to look at things and say, hey, our clients can't get what they need anymore. We're used to using solutions from NVIDIA, from NXP, even Raspberry Pis. And a lot of those were going early end of life or just not available. So we were kind of looking around and saying, what can we do about this? And we started talking to Renesas and realizing, hey, their fab situation is actually a lot better than some of these other companies. They work with TSMC, they work with Samsung, they have fab in Japan as well. And they actually had parts that really kind of checked all the boxes. So we started developing a SOM with them. And once we started doing that, it's funny how the universe kind of talks to you. We started having conversations with other people who had these problems. Another local company, Novax Industries, who they work on pedestrian safety. We ended up talking to them and, we realized that, they had really a whole understanding of this pedestrian tracking problem at intersections that really needed a piece of technology that we were already working on because of this SOM we were developing with Renesas. So, we've kind of been working with them, bringing together some of our hardware expertise and some of our expertise in computer vision. We do a ton of computer vision work. And they're bringing together really a deep understanding of kind of traffic problems, what it means to sell traffic systems to the city. And also, they have their own solutions in terms of automated traffic control and power systems that are kind of uniquely required to work at traffic systems. So the solution we're exploring there in that case, so the SOM we're working on is based on the Renesas RZ V2L. So it's an ARM SoC that has a dedicated neural processing unit. So basically, it's a piece of silicon that does special linear algebra operations that are perfect for running object detection and objects and image segmentation algorithms. So if you think basic convolutional neural net stuff that you can generate in TensorFlow in a known and next format, this SoC will take that and run it. And it's basically comparable to a Jetson Nano, but it uses half the power and it costs a lot less, which allows potentially a much lower cost way to do pedestrian tracking at the edge. And you can run the compute at the edge because this thing is cheaper. So now, we're looking at other solutions. Like obviously there's a lot of people looking at this problem. There's been a significant uptick in pedestrian fatalities in intersections during the pandemic and even before that. So now a lot of cities in North America are basically signing on to this Vision Zero pledge where they want to try and get to zero pedestrian fatalities. So there are a bunch of companies like Bosch, for example, has developed a solution in this space. I think they're selling the camera for like $3,000 or $4,000 USD per camera, but it also comes with a subscription, so hardware as a service, and you basically stream all of your image data to the cloud, and it's something like $2,000 a year for the first year, and then $500 from then on, which is a pretty expensive model for the city to sign up to. And we're thinking, that makes sense, I think, if you're doing the compute in the cloud. But some of these applications, I think, in the long run, as the compute, like the example I just gave, where you basically have something that's 2 or 4 times more performant than a Jetson Nano, right? And the Jetson Nano is not an old piece of tech, right? So there's a real trend here in industry, and what we're imagining is going to happen is that some of this is going to make sense to move to the edge, just from an economics kind of perspective. That doesn't mean that there wouldn't necessarily be a hardware as a service kind of model here, but if you can push that compute out to the edge, then potentially you don't necessarily need to use all that bandwidth, and you don't need to store a bunch of things. So we're working with them on that, and we're kind of developing support for cameras and things that'll be good options for low light and outdoor.
Yeah, and I would imagine in a case like this, machine vision at a pedestrian crossing, latency is going to be critical here. And so a cloud solution might work in 99% of the cases. There might be a storm or something that disrupts the system to some extent. And I think that's also a consideration here. This is an interesting trend, though. I mean, I've interviewed over the past, I think, year or so, a couple companies that are more on the design side in the semiconductor value chain, designing chips specialized for applications like machine vision. So I think that's one trend of saying, okay, we now have enough scale in some of these applications to do design specifically for them, and then we can be much more efficient in terms of how we design the packaging or how we design the chip itself. That still takes a lot of time to get off to market, right? Because they're going to have the same challenge trying to get this into a fab and get manufactured as anybody's having today. I think your approach is quite interesting to say, okay, you actually found a situation where you had excess capacity with Renaissance, it sounds, or at least less pressure than some of the other manufacturers are having, and you were able to kind of design that for a specific purpose and basically repurpose that. So I think that's an interesting approach to kind of navigating the challenges we have today.
Yeah, we were looking around for something that addresses the issues that our clients are currently having, but also is a bit future forward and looking at the problems that they will be able to solve potentially. So it's a brand new solution, and we're kind of benefiting from being on the bleeding edge a little bit there. The other thing to say too is it does have a pin compatible version, the RZ G2L, which is kind of more similar to say a Raspberry Pi solution, and we're using that in other places. So like if you want to have an IoT gateway, it's kind of a 2-for-1 in that regard. So it really was kind of a no-brainer once we looked at it a little bit more.
How far do you guys extend into machine learning? If we're looking at the Muon example, I imagine you have a certain kind of density, but then you could say, well, over a kilometer, we have an average density. It could be, in some cases, it could be that it's one specific area, like 20 meters of that is extremely dense, or maybe there's a moderate density across the entire range. So I guess there's different configurations that could lead to kind of some kind of average. So I assume you have kind of complex models behind that helps interpret the data. Do you, as MistyWest, do you get involved in helping companies to develop the ML, or do you kind of step away at the end of let's say the border of the hardware?
Yeah, it's an interesting question. Primarily, where we spend effort is when it makes sense to get these things on the edge. We'll invest the effort in terms of firmware development and things like that to get them running well on the edge and get them deployed at scale on the edge. In terms of, Ideon, for example, they have their own expertise in-house that is really relevant to the problems they have to solve there. It's actually, in terms of like turning muon tomography data into meaningful, actionable insights for a mining company, there's a lot to be done there and a lot of really domain-specific knowledge. There's actually other sensor modalities that they want to integrate, so things that are more industry standard right now, like magnetometry and gravimetry. But overlaying those data sets with muon tomography data is really complicated because the nature and how they measure is so different. So those are things where those are real ML AI problems. There's a real challenging inversion problem to solve there as well. But it's not a place where we have a ton of expertise, and it does make sense, I think. And I would advise my clients for things like that often to hold that expertise in-house because it is going to be really critical for them in terms of unlocking their full value proposition.
Yeah. Okay. Got it. So we've been discussing a bit where you are today. I think this area is very interesting because, it's on the one hand, it's a long tail, and we're dealing with B2B environments. Also for large corporates, kind of validating the concept matters a lot, right? It's very difficult for companies to move forward with a a new solution development until they, either see one of their internal units succeed, or they see a couple competitors start to develop a solution that has some traction on the market. And I feel like we're starting to see that in high enough volumes that companies like, I know here in China, a number of multinational pharma companies are starting to look into IoT devices for helping people recover from Alzheimer's and other diseases and so forth. So we're kind of reaching that critical mass where executives are looking at and saying, okay, we have confidence. We have confidence that collecting data from IoT devices, analyzing it, will allow us to help solve business problems. And then they have to, still figure out the user journey and the business model and so forth. And so there's a set of challenges there that the companies are working on. But at least I feel like we've kind of reached that area where the confidence exists that these solutions in many areas can kind of address real needs. If we look forward to the next 5 years, first, do you agree, or where do you see that market? And then if we look forward to the next 5 years, what would be the things that excite you about what is going to be possible, whether it's trends in terms of how companies are, from a business standpoint, how they're investing and, their ambition level, or whether it's from a technical standpoint in terms of how developments will enable capabilities that previously were very challenging and costly to build. So let's kind of cover this in two parts. First, where do you see us today? And then looking out over the next 5 years, what excites you about the potential for development here?
Yeah, I think in terms of where IoT is today, it's a really exciting space. It is definitely a bit of a red ocean in some ways. So like if you look at just taking, for example, like IoT frameworks, so like solutions in the cloud that integrate IoT devices, I probably come across, one new example every 2 weeks or something like that. So, like Siemens has MindSphere. There's a company called Losant. There's Balena for fleet management. There's obviously Azure and AWS IoT. There's Ubuntu Core. There's EdgeX. That's just a few. I have a list that's like another 20 items long. So there is a ton of diversity in terms of what's out there. And I think what you're going to see in the next 5 years is some consolidation in those areas where we start to see some winners and some losers. That said, I think maybe backing up a bit, I think I might get the numbers slightly wrong here, but I think back in 2010 or something, Cisco was forecasting what they were expecting to see in terms of IoT growth in the next 10 years. And I think they were off by like a factor of 50% or something like that by 2020. Just in that, and I think the reason why they missed their estimate is because the reality with IoT, especially in the commercial and industrial spaces, there's a lot of unique components, different systems. There's a lot of diversity. It's not like the iPhone where everyone is expecting a certain user interface and everyone is just going to go buy an iPhone and they'll be happy with it. The reality is that, every factory, every store, they all have different interfaces and different needs, and there's always going to be some degree of customization there. So I think there's going to be some consolidation in the next 5 years, but I don't know that it's going to go full hockey stick as a result of that. I would still expect there to be some niche things happening. And then on the technology front, the example I brought up with this Renesas SoC, right? Like that's going to keep happening in the next 5 years. And I think there are applications right now that people aren't quite thinking about that are going to start to become viable, that people just aren't really expecting. Like maybe not in 5 years, but maybe in 10. You could imagine a situation where you buy, a dash cam or something that is battery powered. You just stick it to your window or whatever. You leave it there and it has, its own machine learning algorithm that's running. And whenever something interesting happens, it'll upload that to the cloud or something like that. And that thing could cost like $10. It's almost like a disposable, right? So that kind of technology, you could see that in, the 10, 15, 20-year time frame, maybe even earlier. And there's a bunch of technologies that are enabling it, right? Like, one of them is the compute element that I was talking about. Not only are computers getting even more powerful with, these more dedicated processors, but like the laptop I'm on right now, it's a Microsoft Surface Book and it's based on ARM. So it uses like a quarter the power of its Intel predecessor. So it can be powered over a USB-C connection. Those are both examples of compute, but also the battery power density is going up as well. So, and cost is going down for those batteries. Solar cell efficiency is going up as well. So at some point you get to these situations where cost is also dropping. You can have these very ubiquitous connected devices, and they'll just start to unlock applications that right now just don't really make sense and are a little bit hard to think about.
Yeah, no, I think that's a great point. Often, we end up talking about, to some extent, the cutting edge, or the topics like edge AI that are a bit more exciting. But a lot of the most meaningful innovation is about simplifying, right? It's about reducing the cost structure. It's about simplifying deployment, and that's what makes it possible, right, to do widespread deployments, to make a business case, and then in the end to really impact, right, how people live and work in the real world, right? Is getting the product out to market. Good. I think we've covered a bit here. I mean, I guess this is it's an interesting topic because you could take it from so many different angles, right? Is there anything critical that we haven't touched? I mean, we haven't even touched on security and so forth. I mean, that's a whole nother kind of rabbit hole that we could get into. But anything else that we haven't touched on here that's really critical to the work that MistyWest is doing?
I think we've kind of touched on most of it. We do a decent amount of work on wearables, Bluetooth connected wearables as well. One of the companies we work with, Fatigue Science, they do their own, basically a metric for fatigue. Right now, they're working primarily in mine sites and things like that. But we were originally helping them when they were working with the Cubs when they won the World Series. They were all wearing wristbands that we'd helped develop, and I think that's another space where there's a lot of changes going on too. Where I think when we were working with them, it was maybe 5 years ago now. But since then, Fitbit has released their own SDK. They got bought by Google. And a lot of these kind of wearable technology plays have changed from making wearable hardware to software plays running on wearable SDKs, where, you'll run your algorithm in an app that runs on the Apple Watch or whatever, really leveraging that hardware. So that's definitely one trend we've been seeing. I don't know if there's too much else to mention. I mean, obviously, it's a topic that could just keep talking about, but maybe I'll park it there.
Yeah, well, maybe that's then something to look out for the future. What are the business models of the future when you have? Because I also know a lot of companies that are looking and basically saying, we can use some kind of hardware to create a data set and a gateway to the customer. And then, we just open that up and let people build things on it, and we collect a toll, along the way. And a lot of room for business model innovation here. I think that's always for us a very exciting place. IoT One, we're not as technical as MistyWest, so we're much more playing on this side of the equation.
It's definitely an important element of it, and it's something that as I get more and more experience, I learn to appreciate more and more. That getting the business model right, figuring out how you're going to monetize, is not an insignificant part of the journey. Often.
Yeah, exactly. Great. Well, if somebody is interested in having a conversation and learning more about what you guys do and maybe doing a project with you, what's the best way for them to reach out to the team?
Yeah, there's just our website, so mistywest.com. There's a contact form in there you can reach out to us by. You can also reach out to me, Taylor at MistyWest, MistyWest.com.
Awesome. Taylor, thanks for taking the time. Really appreciate it.
Yeah, thank you so much.
Thanks for tuning in to another edition of the Industrial IoT Spotlight. Don't forget to follow us on Twitter at IoT1HQ and to check out our database of case studies on IoT1.com. If you have unique insight or a project deployment story to share, we'd love to feature you on a future edition. Write us at eric.walenza@IoT1.com.